Okay, welcome to ETCS5201. This is Artificial Intelligence and Machine Learning 2. And so, presumably, if you're in this class, you have already made it through Artificial Intelligence and Machine Learning 1. So, today's course introduction and content overview, you're probably familiar with most of this. We're going to kind of go over the syllabus, what to expect. Let's go ahead and just jump right into stuff here. So this will go a little faster than it did for the last class. But the idea of today's class, we're not really going to cover much in the way of content other than we are going to get an overview of what we're going to cover this semester. So the idea here is we'll give a real quick overview of the syllabus and what to expect there. It's really the same as what it was in the previous class, but I do want to at least talk about the content and what we're going to look at with respect to that. Now, here's our agenda for today. Go over the syllabus, look at the details, spend a little bit of time on looking at the content and the course modules. This class, just like the previous one, is broken up into individual units. We'll look at those, and then we'll finish up like we did last semester with just a really quick overview of that teaching philosophy and the course philosophy again. It's been a while since we talked about that. Let's talk about it again, just so we know where things stand. All right, let's go and kick things off. So first off, here's the syllabus. Has a structure. So if you look at it on the course page, instructor information, the course outline, objectives, and student learning outcomes. Those can be useful at the beginning as a way to ensure that you know what to expect, both content-wise, but also at the end of the semester to know what you're going to be coming away with by the end. And then there's part 4 has a schedule. One word of caution about the schedule. The schedule is a little bit flexible in that it largely covers what we're going to be covering this semester, but if everybody's struggling on something, or if I see something where there's an opportunity to learn more or dig deeper into something, we might slow down or spend additional time. Some places we might change the assignments around a little bit. So don't treat the schedule as absolutely 100% kind of airtight, exactly how it's going to be. There will be some flexibility there, and that's because sometimes the best way to teach is to have that flexibility when we're doing that. So do look at the schedule, but keep in mind that as we go, if I make course corrections or adjustments to that, we'll talk about it, and I'll mention that. Now, the grading policy we'll talk about, the course policies we'll talk about, but we'll gloss over a lot of that because you guys have been through the previous class. All right, let's go ahead and get started. Instructor information, you all should know me by now. My name's Paul Yost. My office is there. That's the Advanced Technology Center building, room 307, and that's on Shawnee State University's campus. My office hours are posted on the course site. And for my phone number, that's also listed on the syllabus. That's my mobile number. Look that up on there. The reason I'm not putting it on here is this time is this does make it onto YouTube, and I don't want strange people contacting me and having access to that. My email is listed on here, though. That's kind of public information if people know where I teach, so I'm not worried about that. But the phone number, look on the syllabus to get that. Now, the syllabus does include a brief bio of me. It's required by the state, so you know who's teaching your class and why they're teaching it. If you're interested in that, read through that. It tells a little bit about my background, what I've done, and I'm not going to toot my own horn and go through and read that to you and try to convince you that of anything. So if you're interested in that, check that out on the syllabus. Now, let's go ahead and get into some of the actual syllabus information that's most relevant. Office hours, those are posted on the syllabus. They're also on the course page as a separate document. I will make myself available during those times that are listed on the syllabus for face-to-face meetings or video chat. But keep in mind that if you can't make any of those meetings, times for some reason, just reach out to me. We'll set up an appointment. I can be flexible within whatever else I have scheduled, whatever other obligations I have, but I don't mind. Like you need a time on the weekend or on a Friday or whatever. Just set up an appointment. We'll figure it out. So in other words, if you need something, reach out. Don't just sit there and worry that you have to wait for office hours to roll around. My email policy, if you do send an email, I do try to keep up with those pretty regularly, but I try to keep up with those during my office hours, but I do prioritize face-to-face meetings and people that call or video chat during those times. So I might get behind at times. So if you do need something that's urgent, if you need help with something or you have some emergency and you need to contact me, either call or text, because that will get to me immediately, more easily than sending an email and then waiting. Now, the course description. Now, you have been through the prior class, so this is a continuation of that. So let's go ahead and read the course description. It says, this course continues ETCS 5200 with a focused exploration of modern machine learning and deep learning systems. Students implement perceptrons, multi-layer neural networks, and backpropagation before transitioning to professional frameworks such as PyTorch. Topics include representation learning, word embeddings, tokenization, and the transformer architecture that underlies large language models. Through hands-on projects, students build and evaluate neural networks, neural-based learning language systems, while critically examining limitations such as overfitting, hallucinations, and bias. Emphasis is placed on understanding how neural networks learn and how contemporary AI systems operate internally. Now, there's a lot in there. That's pretty dense stuff, but the difference between last semester and this semester is the stuff we're doing this semester is largely based on neural models. In other words, modeling the biological way that nerve cells work and learning happens. And that underpins a lot of modern AI, including large language models. So we are going to get, we're going to start at the very beginning of neural networks, which is the simplest kind of neural network you can have, neural system you can have. In other words, like a single neuron. And we're going to move all the way up through large, deep learning systems like large language models and look at how those work, including building our own systems and experimenting with those as we go. Now, the course objective, again, this is similar to what it was last semester. I want to provide you that kind of nuts and bolts understanding of how these things are built, how they operate. I think it's important to have understanding of that. And so I want you to learn by doing. In other words, this isn't just going to be a class where we just talk about things and like, oh, that's like a survey class where we're just like, oh, here's how the large language model does. Let's play with ChatGPT and see what it does. This class is going to be a little more foundational than that. And wherever possible, I am going to continue that method that we used last semester where I avoid black boxing solutions. We are going to have to move up to some larger frameworks in this just because we don't have a lot of time this semester to write it all ourselves from scratch. I do want you to understand what's going on under the hood, but we are going to use things like PyTorch. We may use some other things as well. So be aware that that is a possibility. Pardon the dog barking. Okay, apologies about the dog. If you remember from last semester, Loki, he's this little black and white dog. He's high anxiety, so it may happen again. Anyway, as I was saying, we're going to try to avoid those black box solutions as much as possible. But this semester, it's going to be a little bit unavoidable when we get to some of the larger deep learning networks. We're going to have to use some frameworks. But I do want you to understand how those frameworks work and what's going on under the hood. Now, the next thing here is the key topics this semester. Obviously different than last semester. Last semester, we were more focused on the more probabilistic, statistical side of artificial intelligence. This time we're more focused on the neural network side of um, artificial intelligence and machine learning. And so this semester we're going to start off at the very beginning of those kind of neural systems with perceptrons, move into multi-layer neural networks. In other words, move from simple to more complex. Look at how those learn with gradient descent and a method called backpropagation. And then we're going to get into deep learning with more complex systems. That's where we're going to switch to using a framework that's going to make that a little bit easier than writing it all ourselves. But we're going to start out writing it ourselves so we understand it. Then we're going to move to a framework that makes it a little bit easier for us and is also faster. It's optimized so we don't have to wait as long during training of these things, especially when we get to much larger networks. That becomes important. We are then going to look a little bit at kind of some recurrent and specialized network architectures. And that's going to move us into where we're going to start wading into large language models. And that's where we get into tokenization and byte pair encoding. This deals with taking text and dividing it up into chunks so that the neural network can effectively learn from it and process it. We're going to look at word embeddings. That is taking a word and turning it into a representation that encodes meaning along with that word relative to other, almost like a conceptual meaning that goes with that word in kind of a high dimensional mathematical space. This will make a lot more sense later in the semester. And then we're going to look at the transformer architecture, which underlies the bulk of large language models that we see have proliferated recently. And then we're going to look at large language model pipelines, some applied large language models, and ways that we can use the transformer architecture for a variety of different tasks. And then at the end, we're going to finish up with looking at some of the weaknesses and some of the problems that we may encounter with that. So things like hallucination issues, bias that gets trained into those, and then potentially some ethical considerations at the very end. Now, we don't have this semester's or this course is a little bit condensed time-wise, so we're going to have to spend our time wisely as we go through this stuff. I'm going to try to make sure that we get the best foundation we can as we go through all of the material. Now, same kind of prerequisites and skills that we had last time, although you should have completed the ETCS5201 course or have instructor approval. It's not absolutely necessary that you've completed that course to be successful in this one. In other words, we are covering different topics in this class. Neural networking, neural networks are a different animal than the kind of AI systems and machine learning systems we did last semester, but it certainly helps to have a foundation in those. There are going to be topics, especially from information theory from last semester, that you're going to see again in here. But overall, the skills you need: basic arithmetic and algebra skills, no really high level math other than those to start with, good problem solving skills, some programming experience. We're going to use Python, but any language it would be suitable as long as it's a high level programming language of some form or another. And then obviously that sense of excitement and curiosity and that desire to learn new things. Those are probably the most important things on this list here. If you're excited about this stuff, if you're ready to go and do some really cool stuff this semester, that's going to go a long way toward like being the driver for you figuring out and being motivated to play with this stuff. And we're going to have a lot of fun this semester with doing some really interesting things. And you're going to learn a lot. Now, the course structure, same as it was last semester, so I'm not going to spend a lot of time on this. The videos are going to be linked on the first or really the second page of the lecture slides. There'll be a link to the YouTube video presentation of the lecture slides. Also, I'll post the lecture slides in the form of a PDF. And the advantage of that is that gives you the ability to watch the video presentation listen to the thing. You can pause it. You can rewind it. You can make notes. You can watch part of it for part of the day and pause, and then, I don't know, eat dinner, put your kids to bed, whatever you need to do, unpause, watch the rest of it, watch it in chunks if that helps. But then if you later on you need to come back and reference a particular slide or a particular detail, you don't have to wade through all of the video content to find that. You can just go to the PDF, jump ahead to whichever slide you're interested in, and read the content off of there. Do be aware, though, that sometimes the video has additional information that's not in the slides, especially when we get to some of the coding portion of this, that I will sometimes switch to a programming screen where I code live. In other words, I'll start with a blank code editor, or I'll pull up code that has already been written and make modifications to it. And that is not always in the lecture slides. So there might be, but usually there'll be a lecture slide that says, let's write some code or something like that. And then I'll switch to that. So you may need to watch the video if you want to get all of that content as well. Now, for the assessments throughout the course, there'll be, just like there was last semester, some kind of check-in assignments, some quizzes that periodically pop up, some kind of written labs and assignments where you investigate or experiment and then describe what you did, or sometimes there's programming assignments where you'll write code, turn in the code, and then there's a chat room participation as well. So in other words, you'll log into the chat room, talk about what it is we're working on, and I might have some open-ended questions that I post sometimes at the end of the lecture and say, hey, go to the chat room and tell me what you think about this. And make sure to pay attention to that. Go in there. Also, be sure with all of these things to observe the due dates on those. If you do have a problem that arises with meeting one of the due dates, just communicate with me. Let me know. I'd rather have you reach out and say, hey, I had this problem that arose. I'm not going to meet the due date by Friday at midnight, but I have Saturday open. I could get this done by the end of the weekend or whatever. And if you had some sort of issue that arose, rather than me saying, no, I'm not going to allow you to do that, unless there's a good reason for me to say that, most of the time I'll say, like, I'd rather have you learn the material and not get penalized for that. I don't want you to give up. I want you to do what you can to learn this material, and I want to be flexible and fair. So if you do have an issue that arises, the short way of saying this is just make sure to communicate with me. Make sure to let me know if you're having an issue beforehand rather than after, and that way I know and can communicate with you how we'll deal with that and how I can help you with that. Now, the course outline. This is different than last semester because we're covering different material. We talked about a little bit of this in the course description earlier, but this semester we have, or this course we have 7 units, so more units, but they're a little more granular in some of them. So for example, we've got Unit 1, which is Foundations of Neural Learning. That's where we're going to focus on learning the very basics of kind of the biologically inspired neural learning, where we simulate a neuron, simulate multiple neurons, and then we're going to build up into using those together to do more complex problems. That's when we get into Unit 2 with multi-layer networks and back propagation, and figuring out, okay, how do we solve more complex problems with these neural simulation learning systems? And then Unit 3, we get into deep learning, where we're now going to have much more massive systems, and that's where we're going to transition to using, instead of doing it all from scratch, we're going to use a professional grade framework called PyTorch, which is going to allow us to make these large deep learning systems that also are very performative, that are not slow, because PyTorch was designed to be optimized, including having GPU optimization, but you don't need a GPU, an NVIDIA GPU to run the PyTorch stuff. So we'll get into that. And then we're going to get into what's called representation learning, that's where we start wading into the large language model space, tokenization, sequence modeling. Again, this is moving into large language modeling. And notice this is similar to what we did last semester with the Markov chains and the probabilistic thing, but in this case, all the language modeling we're doing here from Unit 4 through Unit 7 is still neural based. We're using neural networks for our language modeling rather than just a pure mathematical, statistical approach. It's a trained system that works differently, and we'll get to that, and we'll talk about how that works. And then we're going to talk about that transformer architecture, which has really kind of revolutionized that language processing. That's what ChatGPT and Gemini and Claude and all of those things are based upon. And then we're going to finish up with the large language models and various applications of them. And then at the end of that Unit 7, that's where we're going to talk about some of the limitations of those that we mentioned. Now, a lot of that might not make a lot of sense right now. It'll make more sense later, I promise, as we go through. Again, start from the beginning with baby steps and then build our way up into essentially what modern AI, large language models do. And we're going to do that relatively quickly. But the key word that underpins all of this semester is that word neural. So that's going to be from Unit 1. It's going to stay there either front and center or under the hood all the way through Unit 7. So we did not have neural systems last semester at all. For the last class, this class, it's going to be throughout all of this. And those are an important part of the AI space. So we're going to spend this semester, this class, looking at those. Now, the grading policy, same as it was last semester, 40%. The largest amount of work is the homework, programs, projects, quizzes, and chat participation. That's where you're going to spend most of your time. So that's where you get most of the points. But then we also do have 2 exams, a midterm and a final. The final is, by its very nature, going to be comprehensive, meaning that everything we cover in the course content is fair game for the final. And I have the rule, once again, you have to pass the final exam to pass the class. Now, if you did the work and take the final exam seriously, you should not have a problem passing that. And again, that's my kind of gatekeeper to make sure that people that get through the class have learned a sufficient amount of material for me I take the grading seriously. So it is my quality control, my stamp of approval that says, yes, you have succeeded in learning the material. And that will give you something that you can be proud of. Now, speaking of the grading system, it's the same as it was last semester. And again, remember that you do have to get a passing grade on the final to pass a class, which, since I do round up, it'll be 15, or I do round, I should say, 59.5 or higher would be considered a passing grade in the class. And you can see the grading scale for what grade goes with what that's listed there. Now, course policies. And rather than going to the syllabus and looking through that, let's just go through the important ones here. The due dates, we said that earlier, that all the assignments will have due dates. If you are struggling or have issues, reach out, communicate with me. That's the biggest thing there. Other than that, you have to observe the due dates. Make sure you observe those. And there are times where I'll go over a solution to something. I can't let you turn in an assignment or a quiz after I've gone over a solution for it. So just make sure you observe the due dates, or if you're struggling and can't for some reason have an emergency, struggling with something going on, communicate with me. Let me know. Now, academic integrity. We talked about this last semester, but I'll do it again here. So submit work that is your own. Don't submit work that isn't your own. If there's something where you're supposed to gather results and gather data, do not fake the results or the data. In other words, what we're doing in here, this is computer science, just like any other science. It is academically dishonest and lacks integrity to fake some sort of data or results and turn them in. Also, it lacks integrity to plagiarize something from someone else. Take somebody else's code and turn it in. take somebody else's results and turn them in. And that includes taking things directly from an AI system or a large language model, or downloading something from somewhere else on the internet. So my AI policy in here isn't that you can't use it. This is an AI class. We're going to even be writing and creating some of these things ourselves. So it wouldn't make sense to say, they're evil and you can't use them. We're going to be making them. But what I do want you to focus on is, if you're relying on it to do your work for you, where it's kind of circumventing the hard work that you're putting in to learn and understand, that's bad for you. That's not good. That's not helpful for you getting out of this class what you should be getting out of it. So if you're using it as a tutor and to help you learn things, that's great. It can turbocharge your learning. It can make you able to do things faster and learn things faster and understand more quickly without having to wait and ask me questions. You can ask the AI questions. Keep in mind, it might be wrong sometimes, or maybe it's not always to be trusted, but do use it for those kinds of things. But do not use it to say, oh, I'm running behind on this lab, I don't know how to do it, I'll just get the large language model, I'll get ChatGPT to do it for me, and I'll just turn that in. And then maybe I'll figure it out later, maybe I won't. Now, here are some scenarios. We talked about these last semester, but I think it's worth going through them again. My suggested kind of scenario evaluations are: you're using it as a tutor or a learning tool to explain things to you, to help you learn. That's good. That's actually fantastic. But if you're using it to write your code for the programming labs, and the code that it's writing, you don't understand what it's doing, but let's say you run it and it works, and you're like, okay, cool, it did it, I've satisfied the assignment. Really what satisfies the assignment is you learning the material, not just turning something in and getting a check mark for it. And think of it that way. Think of it as like, if you're training in a sport, you want the practice to be hard so the game can be easy. And that's kind of what we're doing here. Think about these assignments that you're getting as those are the practice. That's sometimes it will be difficult. You got to think about things, and think about AI. If you're using it as a coach to help you in practice, that's great. But if you're using it as, hey, coach, go play the game for me, you're never going to get anything out of that. Kind of like you go to the gym. If you have a good personal trainer, they are going to help you and motivate you and teach you the right technique and the right things to do. But if you go to the gym and say, hey, personal trainer, get on the weight machine and lift the weights and then run around the track, and all you do is sit there and watch them, you're not going to get anything out of that. You're not going to get better. And that means the practice will be easy, but then the game is going to be really hard when you go out there and have to do the stuff for real. We want it to be easy game, difficult practice, but we can make the practice a little less difficult by using AI. So that second good there, use AI to explain difficult concepts that you're struggling with. Again, that's like a coach or a mentor or a tutor. You ask it, hey, I don't understand how this part of neural networks works. Can you help me with that? It'll help you with that. And it'll give you a thing. You say, okay, I still don't understand this little piece of it. It'll give you feedback and help you with that. Or maybe you say, there's this piece of this code that I'm not clear about why it's there, what it's doing. It'll help you by providing maybe some resources or explanation. That's a good use of it. But if you just say, hey, here's this question, you copy and paste its answer, that's bad. You're not doing the thinking. You're having it jump in and do the work for you. You're not figuring it out. Just like in class, for example, if I'm in class and you ask me for help on an assignment, there's two approaches I could take. I could say, okay, move out of the way and I'm just going to do the work, write the program for you, but you're not going to learn from that. So generally what I do, even though I could do that, is I'll say, I'll look at your code and I'll say, okay, well, let's look at line number, 52. And then let's talk through what's happening there and let me help you understand where you're going wrong. Use the AI in the same way as that. Use it as a tutor and a coach and a trainer rather than having it jump in and solve your work for you. So the last one there, using it as an assistant to help you research topics and technologies, that's great. works wonderfully for that. But using it to do your work for you, again, bad. Also, in this class, if you do use outside resources or you find a website that explains something or has a little bit of code that oh, that's perfect. That's exactly what I want to do. And you take that code and let's say you understand it completely, put a citation of that in your comments at the top of your program saying that here's this website I got this from, or this Wikipedia page I got it from, or this place I got it from. Just put a citation in there so that there's two reasons for that. One, it tells me that. And then later when you're looking at your code and you see that bit of code and you're like, I don't remember how I came up with this. It gives you a way to look back at that resource, that web page that it came from, and then maybe there's more information you can glean from that. It's a good habit to get into. Now, the course policies, those are on the syllabus. I'm not going to spend the time going through that, but there's stuff in there about the last date to drop. There's stuff in there about the incompletes in the class. If you get one of those, there's stuff in there about a library and utilizing library resources. There's a lot of stuff in there. I would encourage you to read through that section of the syllabus. And if you come across something in there that you have questions about, really anything in there you have questions about, don't hesitate to ask and seek clarification. That's why I'm here. Now, the syllabus will always be on the course site for you to look at and read and go back to, read it over and over again. In other words, you don't have to go back and watch this video to get that information. You can go to the course site, go right to the syllabus, read any of that stuff that you need to. Now, we did this last semester, so I'm going to go through this pretty quickly. But this why are you here question, again, it's helpful at the beginning of every class to remind yourself that you're here to learn. And the thing that I see is a lot of times is this mentality of, I just want to get through this. I just want to get it done. I don't want to spend the effort doing this. Students, when their grades involved, they treat things as, I got to check these things off and get them done, and then that I can be done with this class. But I would like it, instead of thinking like, oh, do I have to do another lab and do I have to take this quiz, and then, rather than treating it as a burden or a checkbox to mark off to get done with something, I would hope that you would look at this as more of an opportunity. And so changing that perspective a little bit, rather than I have to, or I have to get through, I want to be done. I think that there's a real advantage to changing your perception in some ways. And the way I think that you can think about that's a little bit different would be, and that would be to think of the class in terms of this other perspective, that instead of have tos or need tos or checking things off, would be, you get to do this. There's a lot of really cool stuff we're going to be learning this semester. A lot of really fascinating things. We live in a really remarkable time where we have these machines that are essentially magic that we can control and get to do that. So look at this as an opportunity to learn how to control that magic and how to be somebody who understands this stuff. And so I would hope that you're excited by this material. That treat the quizzes as, I get to test myself. I get to see how well I'm doing at this. Treat the assignments as, I get to explore and play and have fun with this stuff. And a lot of it is going to be fun this semester. It's really interesting that we're going to be kind of constructing our own little brains ourselves and then teaching them things and watching their behavior. It's kind of like a little mad scientist experiment that we get to do, where we get to control that. So I want you to, again, think about why you are here. Hopefully it's to learn and expand yourself and get that kind of knowledge and satisfaction out of that, more than checking off a box to be done with something. Now, I talked about this. I'm not going to spend a lot of time on that, but that verb phrase to teach doesn't make a lot of sense. And that's because I want you, it puts the emphasis on the teacher being the active one, doing something to the students, and I'd rather do something with you and pull you along as kind of be your guide, lead you, and I want you to take an active role in uh, upholding your side of that as wanting to learn, and wanting to um, be the active entity, or at least co responsible for what we're going to do this semester. So I don't like it when people try to force me to do things, and I don't think you'll like that either. So again, I think of it like a guide. If I threw a rope around your waist and dragged you up a mountain, across the rocks and the sharp through the thorn bushes and everything like that, you get to the top, you would not have learned anything, but you're going to be sore and scratched up and not very happy. I would rather us walk up the mountain together, and if you get scared in some spots or confused or don't know the right path forward or where to put your feet, then that's my job, is to be your guide, to say, okay, well, let's take a different route. And different people learn in different ways. So if you get stuck or you're confused about something, ask me and I'll take a few steps back and we'll try a different approach to that. So I don't want to just like come in and like teach people stuff and be really authoritarian about it. I'd rather be more cooperative with you. So cooperate with me the same way. Now, again, just like last semester, there's that philosophy that's going to underpin the course, is that what I cannot create, I do not understand. That's a quote by Richard Feynman again, and that's something that I really myself have taken to heart. Is I really like understanding how things work, and in order to figure things out at their deepest level, it requires you to not just talk about them, not just look at them, but to roll up your sleeves, get your hands dirty, and build some things and make some stuff and make something happen, and then watch it happen and then experiment with it and make changes. So that's going to guide my approach to the class. And I had my two famous, not so famous quotes, but maybe will be famous sometime in the future. Probably not. But the idea is, I believe that to truly create, you have to understand. But in order to understand, you also have to first create. And so really, it almost seems like a paradox that you could never create or understand, because this kind of makes a circle here. And so really, we just got to break the cycle and start doing stuff. And so to do that, I refer to this as the paradox of enlightenment, or Paul's paradox of enlightenment. But the idea is, there's no really way forward other than just to, it's kind of like the Nike slogan, just do it, just start on stuff. And so that's what we're going to do, is we're going to talk about some things a little bit, and then we're just going to start doing some stuff. There's a lot of people that just talk forever and they never get around to doing the stuff that they want to do. It's unfortunate. A lot of people waste a lot of their hours and lives talking about what they want to do. I don't know, you want to learn to play guitar? Buy a guitar. Just start playing around with it. You want to learn to play a sport? Buy the equipment and go somewhere where people are playing it and just start doing it. Same thing with what we're going to be doing in here. If you want to create something and understand it, just get started. And that's what we're going to do this semester. We're going to start creating things to understand them. And then the more we understand, the more we're going to be able to create. And that's a wonderful feedback cycle that seems hard to break into. By the way, I have it worded here, but once you're in it, it kind of builds and builds, and that's going to be really fun and exciting for us. Now, we're going to be doing all of these things that we mentioned last semester. Same things here. The biggest ones on this at the bottom there. A lot of this we did last semester with the information theory and patterns in language and machine learning and artificial intelligence. This semester is more going to be neural networks and large language models than that. But we are still going to write code. We're still going to do exercises and create things and do actual stuff. And we're also going to explore and experiment and have a lot of fun while we're doing it. So last little bit here, we're going to take a quick break. So I'll stop this lecture here. Do in between now and the next lecture, if you want to go take a look at the syllabus a little more carefully, there is a more detailed description of each of the units that we're going to cover. Those 7 units, there's a detailed description of each of those. It might be worthwhile to take a look at that. There's also, as we mentioned, the learning objectives and learning student outcomes. Probably worthwhile taking a look at those to get a good sense of what you're going to be able to do, or what we're going to do and what you're going to be able to do by the end of the semester. So do take a look at that. And then look at the course policies. There's a lot of good stuff in there, and links to resources. Just familiarize yourself with that, so later in the semester you'll know what's there and what's not. So we will stop this video here, and then we're going to pick up with class 2, which is still part of unit 1. And this is where we're going to wade into the neural network kind of way of doing AI, which is essentially, interestingly, how you're listening to this and how I'm saying this stuff is using my neural network to do that. And so it's interesting. We're going to use our neural networks to talk about neural networks and learn about neural networks. And we're going to make neural networks that learn by using our neural networks that learn. It's a really fascinating kind of self-referential thing that we have going on here, with humans figuring out how to make computers learn in a way that's very similar to how biological systems learn. And we're going to dig into that next class. So hopefully next time I see you, we're going to be able to spend that time actually learning some stuff. This was a little bit of housekeeping today, but next time we're going to dig in and get into some really interesting material pretty quickly, and then get into some code actually pretty quickly this semester as well. So stay safe until next time, and I'll see you then. And if you ever need to go back, like I said, you can always look at the lecture slides or watch the YouTube video. The link to that is always going to be on the front title card of the slides. All right, see you next time.